A warm welcome to all of you. Today we are going to discuss about the concept of K-means clustering assessment through animation. So we are starting with the three-dimensional space. You can see there are three different axes: x-axis, y-axis, and z-axis, going from -3 to +3. The title entitled to K-means clustering in three dimension. This is cool because we are working in three dimension instead of just two dimension, which is way more like how real data actually exists. Now watch this. 60 little gray spheres start appearing one after another, a kind of cascading in. They are just gray right now, no labels, nothing spacious and nothing special about them. But here is the thing: if you look closely, these points actually form three natural groups in space. There are about 20 points hanging around the coordinates 1, 1, 1, another 20 near -1, -1, 0, and the last 20 around 0, -1, 1.5. But the algorithm doesn't know this yet. All it sees are 60 unlabeled gray points floating around. The algorithm's job is to figure out these groups exist and organize them. Okay, so now we need to tell the algorithm how many groups we want. We are going with 3, which we call k equals 3. Watch this. 3 bigger spheres pop up and there are in totally different colors: one red, one blue, and one green. So one red, one blue, and one green. These are called centroids and they are labeled C1 in red, C2 in blue, and C3 in green. They appear one by one, a kind of growing from their center points. The labels float just above each centroid in matching colors. Now here is the interesting part. These centroids starts at random points 0.5, 0.5, 0.5, and -0.5, -0.5, and 0.5, and 0, -1, 1. They don't lie upon with where the natural clusters are at all, and that's totally fine. This is just the starting point. The algorithm will fix this through iterations. The centroids are bigger and more colorful than the data points. Alright, now the fun part will begin. The algorithm starts its first iteration. It needs to figure out which point belongs to which centroid. So what it does is calculate the distance from every single point to all 3 points. It uses something called Euclidean distance, basically just measuring straight line distances through 3D space. Each point gets assigned to whichever centroid is closest to it. These color lines starts connecting each gray point to its nearest centroids. The lines match the colors: red line going to the red centroid, blue line going for blue centroid, and green line going for green centroid. They are kind of transparent, so you can still see everything. These lines appear really fast one after another, and you can iteratively see the algorithm making decisions. Gradually, all 60 points transform from this uniform gray mass into 3 distinct color groups. Each point is now showing which team it belongs to. After showing us the connections for a moment, the lines fade out away. Now we have 3 group of points, each colored according to which centroid they are belongs. The algorithm needs to make the centroids better representatives of their groups. So it calculates the average position of all points assigned to each centroid. And finally, the red centroid C1 moves to at the center of all the red points, and the blue centroid C2, it moves to the center of all blue points, makes it as a blue centroid, and green C3 reposition itself among the 3 points. The labels following along stay just away each centroids as they move. Finally, the summary of K-means clustering. K-means is an unsupervised learning algorithm that discovers hidden patterns by iteratively assigning data points to their nearest centroids and updating those centroids to mean positions, and gradually improving clusters quality through assign, update, repeat cycles until convergence.